Hi there, this is Math 7, Unit 4, Lesson 4. It's called Half as Much again, and so we're going to be using fractions to describe increases and decreases of different properties or different values. And so you began today's lesson with some tape diagrams here, and it began by asking simply, what do you notice and what do you wonder? And so we had this first tape diagram here, where we noticed that, for example, this portion here, it says equal to 1. And that's about a fourth, and they have a question mark down there. Now in this case here, we might say they're the same color, so perhaps we're adding a portion onto that original one there, and this question mark means what's the whole thing all together? That could be what it's talking about there. Hard to say, but just things you might notice. Over here we have two different colors, and we can see that in this case, the entire thing is 1, but here they've had a different part of it. It's this chunk right there, which they call a fourth. It's a different color than what's left. So maybe they're asking, what if I have a little bit less than something there? Again, just things you might think about and wonder, and you have those conversations in your class today. So today then you went to activity number 2, which is called walking half as much again. And I want you to complete the table to show the total distance walked in each case. So in this first one, it says Jada's pet turtle walked 10 feet and then half of that length again. Okay, so let's think this through real quick. This means that she's walking 10 feet, and then we're going to add to it, because it's an and then, we're going to do half of that length again. So initially we did 10, and then we're going to do half of 10. Okay, so half of 10 is a half times 10, and a half times 10 is the same as 5, right? So you might notice that, you might know that and say, well, I know half of 10 is already 5, and you end up with 10 plus 5 for a total distance of 15. That works out just fine. It's nice when you can tell what that number might be just by knowing it's a nice simple number. If I have a number like 3, I may not know what half of 3 is, okay? Now I have a different little problem, don't I, right? If I knew that it was 1.5, which it is, I could say that's 3 plus 1.5, because 1.5 is half of 3. If not, I could set it up this way. I could say that I have 3, my initial distance, plus, and again, half of 3. Okay, so 3 times a half is going to be 3 over 2, right? 3 over 2, which is the same as 1.5, by the way, plus 3. And so I end up with 3 plus 1.5, which equals 4.5. So it's the same thing. I can do 4.5 or 4.5. When I get to 4.5, now it's a little bit more complicated. I'm not sure what 4.5 is in my head as a half. Or maybe I am. I'm just not sharing it. So in this case here, we take our initial 4.5 and we're going to add to it half of 4.5. Now because I'm working with a fraction here, I'm going to go ahead and just change this into 4.5, just so it makes it a little easier in the next step here for me. Okay, because I'm going to multiply this together. A half times 4.5, I can rewrite that as a half times, and 2 times 4 is 8, plus 1 is 9, over 2. And so this part by itself becomes 10 over 4, right? 10 fourths. That can be reduced. 5 goes in there, 2 goes in there 5 times, and 2 goes in there 2 times. So I'm 5 over 2, which is going to be, well, it's going to be 2.5 so far. Do this right here, 8, 9, 9. Oh, that's what I did wrong. I knew something was funky. Let's back up here a second. Sorry about that. I was adding. Oh boy, see my mistakes? 9 times 1 is 9. Whoops. And then this is 4, so 9 fourths. Can't reduce that. That's not going to work there. I knew something was off there. So 4 goes into here 2 times with 1 left over, so 2 1/4. Okay, so I'm going to do 4.5 and I'm going to add to that 2 1/4. 2 1/4 is also 2.25. Okay, if I wrote it out like that. So now when I add this up, I end up with 6.75 as my solution for that one. Sorry about that 9 there for a second there. A little late tonight again. That's all right. The next one says Jada's robot walked 1 foot and then half that. So we went 1 plus half of 1. Well, half of 1 is just a half, so 1 plus a half is going to equal, and I could say here again 1.5. I could write it down as 1.5. Either of those are going to be just fine. Okay, 1.5. The idea here is that when I get to the x value, and it just says they walked x feet, we know that whatever it's going to be x plus half of x, right? Because the next thing is we're walking x amount of feet, and then, meaning I'm adding to it still, half of that. So it's half of x. So this value here, I could think of it if I wanted to as being my first time. My initial is 1 whole trip times 1, and this over here is half of a trip times my x value, okay? So for my total distance here, I can say it's x plus half of an x for my chart right there. And that's the idea there. So for number 2, it asks you how do you explain how you computed the total distance in each case. And so for us, as we looked at that, we took the initial, amount, and added it to 1/2 of the initial amount. Okay, which is like doing this. We divided, so we divide the initial by 2 and add it to the initial, or the original mark. Okay, so that's kind of the idea there. We took the initial value and added it to half, added it to half of the initial as well. Okay, so that's like our initial value, and we added that then onto half of the initial value is what we did. Number 3, it says 2 students each wrote an equation to represent the relationship between the initial distance walked and the total distance walked. Y equals x plus a half x, and y equals 3 over 2x. Do you agree with either of them and explain reasoning? This is a really important problem for today's lesson, because what we're looking at here is we see that what's taking place is that they both have a y value, and we're trying to decide, does this amount here equal this amount right here? And if we set it up like this, if we think about this being 1 times x plus half of x, like we did previously, we can see how we could actually use the distributive property to write this a little differently, couldn't we? We could take our x's and put our x's outside, and we could say this becomes 1 plus a half. Okay, so what do? We took our x's and we put the x's over here, and then we group together these values, the 1 and the plus a half. So x times 1 plus 1.5 is one way of writing this. I could combine those to say this is the same as x times 1.5, because 1 plus 1.5 is 1.5. And I could rewrite this mixed number as an improper. 2 times 1 is 2, plus 1 is 3. So this could also be written as x times 3 over 2. That's the same value there. So when I look at x times 3 over 2 and I flip this around, let's do some flipping. 3 over 2x, just by moving the order around there. Does that part right there match that right there? It sure does. So by rewriting this, you putting a 1 in front of the x, I can then use kind of like the reverse of the distributive property. I'm going to undistribute things, and then I pull the x out of that, and I write it like this. I can combine these whole numbers to see what I have. So would I agree with them? Yes, I'd actually agree with both of them. They both wrote a fine equation. They just wrote it a different way. They have the same equation. One just put it together like this, and the other one broke it apart like that. Okay, let's look at the Are You Ready for More real quick from today's lesson. It says that Zeno jumped 8 meters. Okay, so on his first jump, he jumps 8 meters. Then he jumped half as far again, 4 meters. So on his second jump, he jumped half as far, which is 4. Okay, Then he jumped half as far again, 2 meters. So on the third jump, we jumped 2 meters. So after 3 jumps, he was 8 plus 4 plus 2, which equaled 14, is where he is after 3 jumps. Zeno kept jumping half as far again. How far would he jump after 4 jumps? Well, so 4, we're going to do half of the last one, which that was 2. So we're going to add 1, and that's going to be a total of 15. For 5 jumps, we're going to do half of 1, so we're going to add 0.5 for 15.5. For 6, we're going to add half of 0.5. Half of 0.5 is 0.25, and that gives us 15.75. Okay? So, this just keeps on going forever and ever and ever. It says, before he started jumping, Zeno put a mark on the floor that was exactly 16 meters from his starting place. How close can Zeno get to the mark if he keeps jumping half as far again? Well, the thing is, he can keep getting closer. He's going to get closer and closer, but he will never reach 16. And that's because what's going to happen is, as I keep breaking this in half, I'm going to get a smaller and smaller decimal that I'm going to add to this, but I'm never going to quite reach a whole number of 16. It's just never going to happen. It's kind of a cool little problem, something cool to think about. Let's look at the next one, 4-3. So on 4-3, it says to match each situation with a diagram. A diagram may not have a match. All right, so let's take a look at the situations down below here and see which ones go with which. First, we have Han ate X ounces of blueberries, okay, and May ate 1/3 less than that. So I'm looking for somebody that ate an amount, we'll just draw a line here, and someone else ate 1/3 less than that. So I wouldn't expect this to be a longer one. It's going to be 1/3 less than it. So think about this. If I took a line and I divide it into thirds, like so, I should have this much less than the original. So I'm probably going to go out somewhere about here, is what I'm probably going to look for. And so when I look at my charts up here, which one has an X and a Y that looks something like this? We'd probably say choice C, right? There's a whole, and this one has 1/3 less because this is broken into thirds. Number 2 says May biked X miles. All right, there's my X miles. And Han biked 2/3 more than that. Well, that means that for Han, he's going to be biking a whole amount, right? Because 2/3 more. So he's going to do whatever the first guy did, or May did. But then if we took this in 2/3 again, we're going to take that chunk right there and we need to add it on to this one to go 1, something like this, 1, 2. Okay, so our Y value for Han is going to be longer than the X value for May because we're adding 2/3 more to that one. Okay, so when I look at my choices here, which one does that? We would say B. B has someone writing X amount and then it adds 2/3 more. These are the thirds, and there are 2 of them there that demonstrate that it's this 2/3 more than the original there. So we would say B for number 2. And number 3, Han bought X pounds of apples. So again, there's my X pounds of apples. And May bought 2/3 of that. So I'm going to break that apart. And 2/3 of that means, once again, I'm going to do 2/3 of that amount, which gets me about here. So as just a little picture of my own little tape diagram, I would look for something that looks like this, which again matches choice C. Alright, so for each diagram, we're going to now write an equation that represents the relationship between X and Y. Alright, so for all these, first of all, let's set them up like this. We're going to make them all equal to Y. And we're going to set it up like this. Y equals some part of X. Okay? So let's see how you might want to think about this one here. So for this one, Y, we notice that Y is larger than X, isn't it? Right? It extends beyond the X value. So that means that whatever I'm going to put here for this value right here and multiply it by X, it's going to need to be larger than 1. Because if X was equal to 1, it would stop right there. Okay, but I'm not going to stop right there. I'm actually going to add a little bit more, aren't I? So I'm going to do 1 and a bit more. In this case, what I have here is I have 1, right? This is my 1 times x, and I'm going to add to it this part right here, because that's the missing link there. So that's going to be the same part as that. So I'm going to add to it 1/3 x. And again, using that distributive idea, 1 plus 1/3, 1 plus 1/3 is going to be 1 and 1/3. And I can rewrite that as a mix, as an improper. 3 times 1 is 3, plus 1 is 4. This becomes 4/3, and we keep the x as an x. So my number in front is going to be 4/3. All right, we'll do another one here, so hang in there with me. A little bit new perhaps. So for b, looking at b, what happens to b? Well, y is our whole value here, no problem. We can see y is longer than x, so I'm going to have a value greater than 1. I don't think I finished my thought on that one before. This 4/3 is greater than 1 because it has to be greater than 1. So this one is going to have a greater than 1 value here, something x greater than 1. In this case, we're going to have 1x, 1 times x, plus, and what am I adding? I'm adding 1, 2. I'm adding 2 of these, and what are these? These are, look at the whole, these are groups of thirds. I'm adding 2/3 x. So to rewrite this one, 1 plus 2/3 is 1 and 2/3, which I can rewrite. 3 times 1 is 3, plus 2 is 5. That's the same as 5/3, and we just keep our x there. So for b, we would say y equals 5/3 x. And again, it's a value in front of x is greater than 1 because y is bigger than one of these. Look at c. Now for c, y is less than the whole number x, right? So we're going to have a fraction here that's going to be less than 1. All right, let's see what I have then. So for y in this case here is not the whole thing. We're going to be taking something away, right? We're eliminating a part here. So think of it like this. This works like this. 1 times x is what I had to start with for the whole thing, but now I'm taking away a part, aren't I? I'm taking away one chunk of, like here, these are thirds, so I'm going to subtract 1/3 times x. Again, group things together, and so I have x on the outside, on this case here, 1 minus 1/3. So be careful with this one. This is a subtraction one. So what is 1 minus 1/3? 1 minus 1/3 is actually 2/3. I'll just slide the x over here, so I end up with 2/3 x, and that's what my equation is going to be. For the next one here, same idea. It's going to be less than 1, so I'm going to do 1 times x minus, and let's see how many parts did I eliminate. I eliminated 1, 2, so I eliminated 2/3 times x from the x value there. So to set this up, I'll do x times 1 minus 2/3, and 1 minus 2/3 is simply 1/3, and we can put the x on the other side. So I have y equals 1/3 x. Alright, and we'll look at more of these in your homework tonight too, so just keep this in mind as you're going through that there, okay? This one we're adding to it because it's longer than the top one, and this one we're subtracting because it's shorter than the top one there. So write a story for one of those diagrams that doesn't have a match. So maybe you looked at letter A where you had 1, 2, 3, and this one was 1, 2, 3, 4, right? In terms of links there. And maybe I say that Maddie ate X pounds of chicken for dinner. He was really hungry. And then I say that Noah ate 1/3 more than that. Okay? And this becomes my Maddie line, and that becomes my Noah line. Alright? And that might be a little story I might make up there. Okay. On your next activity, you do this in class here. It says your teacher gives you a set of cards that have proportional relationships represented 3 different ways as descriptions, equations, and tables. You're going to mix them up and place them all face up, and your job is to, with a partner, to make the matches between the descriptions, with the equations, the tables, and find the matches there, and check your answers with an answer key there. All right, now I'm going to move on to the summary lesson because that's an activity you do with your class. So summary, here we go. Using the distributive property provides a shortcut for calculating the final amount in situations that involve adding, subtracting a fraction of the original amount. Okay, so that's the idea there, what we talked about. So for example, if Claire runs 4 miles and the next day she plans to run that same distance plus half as much again, how far does she run the next day? Right, so there's a couple things there. We're going to say she's doing, again, 1 times 4. Just putting a 1 there because that's the first day. She ran the whole amount. And the next day she runs that same plus half as much. We're going to add to it a half of 4. All right? So again, this is written right here like this. Here's the 1 times 4 plus a half times 4. Same thing we've been talking about. And using the distributive property, we can see that we group together the 1 and a half, and we leave the 4 out here by itself. And so that 1 and a half becomes 1 and a half, or 3 over 2. And those are all still times 4 to help you solve that there. And when you solve it, you still end up with, no matter which way you do it, 6 or like that. Okay? And that's the idea today. So here's an example. You can do it decreasing as well. If Tyler spent X dollars, and we'll put a 1 in front of that, X dollars on a new shirt, and Noah spent 1/3 less, we're going to subtract 1/3 of that amount. Okay, then what would that look like? It says here, then Noah spent 2/3 X. Is that true? Let's take a look. We would do 1 minus 1/3, which is, 1 minus 1/3 is 2/3, and then we keep our X right here. Okay, so yes, that's how that works there. And again, it shows you how that works with a subtraction problem right there. So there's an example of subtraction one for you, just to help you out there. Let's take a look at tonight's homework, and you'll need to use this as you go through it. So here we go. All right. Let's match the situation with the diagram. First of all, Diego drank X ounces of juice, and Lynn drank 1/4 less, right? So here's my X, and here's my Y, and it's 1/4 less, so I should have a smaller amount. And think of it this way. Here's, if I take what he drank, and I cut it into fourths, right? So I start here, fourths. If it's 1/4 less, then I'm not going to include that fourth. 1, 2, 3, 4. The Y value should come to someplace like that. So which one does that look like here? This one, the Y is too long, so it's not A. This one, the Y is shorter. Well, how much shorter is it? This is broken up into 1, 2, 3, 4. And so we have 1/4 of it is not there. So that's going to be choice B for number 1. Okay? Number 2, Lynn ran X miles and Diego ran 3/4 more than that. So again, the same idea, right? If we take this and put this into fourths, why fourths? Because I have a fractional part of fourth there. And we're going to have our X value. Our Y value is going to be the whole thing for sure, plus 3/4 more. 3/4 more is going to be 1, 2, 3/4, right? So we're going to go 1, 2, 3/4 more for our Y value. So we need to look for one that has a short X and a longer Y, right? That goes out an extra 1, 2, 3 of those fourths. So we would say A. And B, so number 3 finally, Diego bought X pounds of almonds. Lynn bought 1/4 of that. So again, I can break this up like so, right? 1/4 of that. So 1/4 of that means that she's going to be getting 1/4 of the whole thing. So here's the whole thing. She's doing this much of it, 1/4 of it. and that would match choice C. Okay, could you write equations for those? You could, and I'd recommend that you kind of figure that out. It'd be a good thing to kind of practice with here, right? So in this case here, if you want to write an equation, we could say that y is going to be equal to, and in this case, y is going to be equal to, think about this, this is going to be more than x, so it'd be x is 1, and what do we add to the 1? We added 3 more, right? So we added 3 more. Now my denominator is going to be 4 here, so we're adding 3/4. Okay, so when I add 3/4 to 1, 1 plus 3/4 is equal to 7/4, and so for an equation I would say y equals 7/4 x. For B, if I'm writing an equation, I have y equals, and in this case here, I know I'm decreasing by 1/4, I should have a smaller number there, but what's taking place though is, when I look at it, I have the whole 1 there, and I am subtracting, in this case here, I'm going to be taking away, yeah, 1/4 less, so 1/4 of that. So 1 minus 1/4 is going to be 3/4 x. So y equals 3/4 x right there. Alright, and for C, we have y equals, again, this is going to be less than x, and look at our story here. It says he bought 1 pound of that, Lynn bought 1/4 of that. Okay, so that's going to be less than that. But now, I can't just do subtract 1/4, it doesn't work that way. Looking here, 1/4 less means that I'm going to be, I can either subtract or I can, well, I'm going to subtract here. What am I subtracting? I'm getting rid of 1, 2, 3 of those, so minus 3/4 x there. 1 minus 3/4, so 1 minus 3/4 is 1/4, and the x stays there. So y equals 1/4 x. It doesn't ask you to write that equation, but I'm just going to put it in there for now so you can look at it and see, because I'm just going to keep coming up with it again and again. So here's number 2, because number 2 does want you to think this through a little bit. Elena walks 12 miles, then she walks 1/4 that distance. How far does she walk all together? Okay, so she walks 12, and then she's going to do 1/4 of 12. Okay, so that's my setup. She walks 12, and then 1/4 of 12. And I need to see which of these are going to match that there. First of all, with A won't work because it's 12 plus 1/4. It eliminates that one right there, the times 12, so that's not going to work. For B, we have 12 times 1/4. Well, that's just that part. It doesn't include the plus 12, so that's not going to work there. C, I have 12 plus 1/4 times 12. Perfect. That's great. Let's look at the other ones. Here, I have 12 times 1 plus 1/4. Well, remember we said before, this can have a 1 in front of it, no problem. And now I can use that distributive property idea to put the 12 on the outside and join together the 1 and the 1/4 to look like 1 plus 1/4. Is that the same idea? It sure is, so D would work just fine. E says 12 times 3/4. Well, I don't think so. This is 12, and 1 plus 1/4 is 1 and 1/4. That's not 3/4. If I want to write this as an improper fraction, I could do 12 times 4 times 1 is 4, plus 1 is 5. So I do 12 times 5/4 like that. So it doesn't match E, but it certainly does match F. So those would be proper answers there. Alright, the next one. Write a story that can be represented by the equation y equals x plus 1/4 x. Alright, I can say that Noah walked x miles, Maddie walked 1/4 more than that. How far did Maddie walk? Right? So So we're saying that he walked X amount, that's what Noah did. Matthew did X plus 1/4 of X altogether for a total thing there. All right. Number 4, select all the ratios that are equivalent to 4 to 5. All right, we can set up a couple different ways. So let's do it like this. Let's go 4 to 5. And we're gonna make it equal to 2 to 2.5. Here I have 4 to 5 equal to 2 to 3. Here I have 4 to 5 equal to 3 over 3.75. Here I have 4 to 5 equal to 7/8. Here I have 4 to 5 equal to 8/10. And here I have 4 to 5 equal to 14 over 27.5. So I'm setting them all up as proportions there to see what's going to be equivalent, if the ratios are equivalent. So when I make the ratios equal like this with that, it becomes proportion. So what do I have? Well, I could do a couple of things. I can see, is there a connection here to go from 4 to 2? That's a half. Half of 5 is 2.5. That works. I could also multiply diagonally and see if they're equal. That becomes 10, and 4 times 2.5 also becomes 10. So that's going to work just fine. For this one, I can multiply diagonals. 4 times 3 is 12. 5 times 2 is 10. Not going to work. Not proportional. For number letter C, we have 5 times 3 is 15, and then 4 times 3.75 is also actually equal to 15. So C is going to work. I use a calculator for that one. Sorry. Over here, D, we can look and see 8 times 4 is 32, and 7 times 5 is 35. And those are not equivalent, are they? Over here, I can multiply, sure. 4 times 10 is 40, and 5 times 8 is 40. That's going to work just fine. And then over here we have 5 times 14, which is 70. And then 4 times 27 is more than 70, because if it was just even 25, 25 times 4 is 100. So this is greater than 100. Not going to work. All right, done with that one. Let's take a look at number 5. Jay is making circular birthday invitations for her friends. The diameter of the circle is 12 centimeters. She bought 180 centimeters ribbon to glue around the edge of each invitation. So she's going to glue around there like that. How many can she make? Well, we need to find the circumference. Well, the circumference of one invitation is equal to pi times the diameter. In her case, the diameter is 12, so we have 12 times pi. And 12 times pi, if you want to put a value for pi, I can multiply by 3.14, right? That could work. Or if I had a calculator with pi, I can put that in there. I'll do 12 times 3.14, and we end up with 37.68. So it's going to take 37.68 centimeters to get around one time. So one loop around is 37.68. So the question is, how many times can I do that if I have 180 centimeters of ribbon? Well, the next step would be to take your 37, and we could say 37.7. You could leave it like 37. You could round it. Again, we're just trying to get close here. And we can divide that by the 180 centimeters that we have. And so 37 divided by 180, whoops, 180, sorry, divided by 37. I'm going to do it the other way around. Apologize for that. So you have 180 is your whole thing, the total amount, and we're going to divide that by 37. That's going to equal 4 point, in this case here, this is 4.8. So I can't make an eighth of an invitation. That tells me I can only make 4 whole invitations with the amount of ribbon that I had. Okay, sorry about that little mix up there. Hope that helps you out, and have a great day.